Dun, dun,
Dun,
dun,
dun,
dun,
dun,
dun,
dun,
dun,
dun.
dun, dun.
This one
The mother of
is the
all.
mother of all problems. It has the new stuff and the old stuff.
Oh my heavens. And I can imagine how excited our viewers are about this, right? So okay, so it's sliding to the right. Okay. So if it's sliding to the right, we know that the friction force is
Going to be to the left.
it's to the left. Okay, so whoops, stupid thing. Okay, so there's our 17 newtons. It's sliding to the right. Friction is to the left. We're going to make positive that way. Let's see, it slides to a halt, so the thing is moving along, right? Okay, it's sliding to the right. It slides to a halt in 15 meters, right?
Now, sliding to a halt, that's a secret code word
Yeah.
for final velocity.
Yep, initial velocity, right?
This can be VI. Slides
V
to a
final.
halt is secret code word for VF equals 0.
0, and then that's our x, right? So in case you're wondering at home what's going to happen here, this is a case where we know 3 of these linear kinematic things. We got to solve that first. So let's solve that over here in linear kinematics land, which is this area here.
That's over there.
It's over there.
The whole thing is like the second that they start adding, distances and velocities and times, you know that you're going to need to get acceleration.
Yep.
That's the whole trick to this. If you start seeing velocities and distances and times, you're going to have to solve for an acceleration.
And so instead of just telling you the acceleration, you have to solve for it, and then it's going to be a problem, I guess, just like the last one we did, right?
Yeah, it's like unwrapping a present.
Yes.
You have to unwrap this present to get the acceleration. It's kind of like you can't make the present work without the batteries.
It's just like a present, only it's a math problem. So, okay, so our x is positive 15, right? We're going to go 15 meters to the right. Our initial velocity, I think, is this guy, right?
6 to the right.
So positive 6.
Final velocity is 0.
0. And then all we really give a hoot about is the acceleration.
Yeah,
So we want to use no t, right? I believe that's
VF squared equals VI squared plus 2AX.
So 0 equals 6 squared plus 2a.
So 6 squared is going to be 36.
And I'm going to put it over here and make it negative. Is that
Yeah.
too big a jump? That's not.
I don't think so.
So negative 36 is, and then that's 2
2
times 15 is 30.
Times A. So now to get A by itself, I got to go negative 36 divided by 30. And that's going to give me negative 1.2 meters per second squared. So in the present analogy, now we have our batteries. Now we can make our other present work.
Now, does it make sense that it's a negative acceleration? I guess, right, because we're moving to the right, and we stopped moving to the right, so we had to accelerate left. So just double check, right? Is that important, Mr. Duggan? Can we just ignore the minus sign now?
Oh, no.
Oh, no, Mr. Duggan.
Oh, no.
Oh, we can't
need
ignore
that.
them. That's a very important minus sign. So now we're going to set up F equals ma. We have an unknown force, and in this case, we really don't know which way it is. I don't know.
Yeah.
Does it would this 17 Newton force stop it in 15 meters? I don't know. Is it, So
Yeah.
this is a real mystery. We got to be very careful about this, right? So positive is to the right. That makes this guy negative, right? Friction forces oppose the direction of slide.
So we're not going to suppose that we know which way the unknown force is going. We're just going to call it F.
Right.
So we do negative 17 plus that unknown force
Right.
will equal 20 times our acceleration.
Always make unknown forces positive and let the math, assuming you can do math, right?
Uh-huh.
Yeah.
That's a tricky bit.
Decide for you. Okay, so here we go. We've got 20, right? And then what do we put for the acceleration?
What we found out.
Yeah, it has to be negative 1.2. So notice, this is a beautiful moment. I mean, if the hair on your arms is standing up, right? The positive-negative system that we use for our kinematics also is used in our dynamics. That's why this is such a beautiful example, right? So it's slowing down, right? Right? That's why that's negative. This is negative because it's to the left. We're sliding right. Friction is to the left. So what's 20 times negative 1.2?
It's negative 24.
Right? So F minus 17 equals negative 24.
So now I got to add 17 to
There we
both
go.
sides. And so we find out that our force is indeed toward the left. It's negative 7 newtons. So
Now-
it's like a braking force.
Yeah, somehow, this is just like another force, like air friction or red elk.
It could be red elk.
Could be red elk, right? Antlers. There we go.
But
right.
it's blue elk.
So the beauty of this is that I don't think not that many people, okay, except for that one kid, right, probably by just looking at these numbers knew that that force was to the left. So you just have to be careful. You got to set it up and let the cards fall as they will.
And at the end, we found out that the force is to the left.
Yeah.
It's all good.
It's also like before 8 o'clock in the morning.